Today, we are diving deep into the science that powers our world. Everything from your smartphone to a spaceship. We're talking about a real battle for the future of power. The trusty old chemical cell versus the up-and-coming fuel cell.
But first, let's talk about a feeling I know you've had. You're about to take the perfect picture. Or you're lost and you desperately need that map, and poof, your battery dies. Why does it always seem to happen at the absolute worst possible moment?
Well, it turns out it's not just cosmic bad luck. It's actually fundamental to how most of our batteries are designed to work. And if you understand that design, you'll understand exactly what might come next.
Okay, so let's get right into it. We're going to start with the technology we all use every single day. Let's call it the old guard of power. We're going to break down how a standard battery actually works.
So the proper technical term for what we all just call a battery is a chemical cell. And really, the name gives the whole game away. It's basically a self-contained little box of chemicals. When you need power, it kicks off a chemical reaction inside itself to release that stored energy as electricity.
Here's probably the easiest way to think about it. A battery is just like a packed lunch. You know, in the morning, you fill it with all the food, or in this case, chemical reactants, that you're going to need for the day. But once you've eaten everything, that's it. The lunchbox is empty. It's not going to magically refill itself.
And that is precisely what's happening inside that battery in your phone. It's a really simple two-step process. First, the chemicals get to work, they react, and that creates the voltage that powers your device. But eventually, one of those key chemicals just gets completely used up. The reaction grinds to a halt, the voltage drops to zero, and that's when we say the battery's gone flat. It's a totally closed, finite system.
So, what if you didn't have to rely on that packed lunch? What if your power source could, at least in theory, last forever? Well, that brings us to the challenger in this fight, the fuel cell. A fuel cell works on a completely different principle. It doesn't store a limited amount of chemicals inside. You can think of it more like a tiny, on-demand power plant. It generates electricity on the fly, and it produces a voltage continuously, just as long as you keep feeding it fuel and a little bit of oxygen. So let's go back to our analogy. If the battery is our limited packed lunch, then the fuel cell is the kitchen stove. The stove doesn't have a set amount of energy stored inside it, right? It just keeps on working, producing heat as long as you keep that gas supply on. It generates power. It doesn't just store it. Huge difference.
So what is this magical-sounding fuel? Well, for the most common and, frankly, most promising type of fuel cell, the fuel is something we have a whole lot of. In fact, it's the most abundant element in the entire universe. It's hydrogen.
What the fuel cell does is it takes that hydrogen fuel and it combines it with oxygen, and it gets the oxygen just by pulling it from the air all around us. And that simple, controlled reaction is all it takes to generate a steady, continuous voltage.
And you know, this is the part that really sounds like it's straight out of science fiction. After this incredibly elegant reaction between hydrogen and oxygen, there's only one single byproduct. That's it. No smoke, no carbon dioxide, no nasty pollutants. Just pure, clean water.
Okay, this tech sounds amazing in theory, right? But where is it actually being used? Let's take a look at where fuel cells are really making an impact in the real world, from the vacuum of space right down to our highways.
So you might be surprised to hear that fuel cells are already a proven, reliable technology in one of the toughest environments you can possibly imagine, space travel. And they are perfectly suited for it. They have no moving parts, which makes them incredibly reliable. They're super compact for the amount of power they kick out. And maybe best of all, that water byproduct, it isn't waste at all. It becomes drinking water for the astronauts. How cool is that? It's just an incredibly elegant, closed-loop system. Now, back here on Earth, the most visible place you'll see this technology is in transportation. We're now actually seeing cars and buses hitting the streets that are powered by these hydrogen-oxygen fuel cells instead of a normal combustion engine. And this really gets us to the heart of the real-world trade-offs. On one side, you have fuel cell vehicles, and they offer this fantastic vision of the future, right? They're quiet, their only emission is water, and with fewer moving parts, they could be way more reliable. But they're going up against a century of dominance from petrol and diesel, which have this one massive advantage: convenience. Their fuel is easy to store, and you can find a gas station on pretty much every corner.
And that right there is the real bottleneck. Petrol is a stable liquid. Hydrogen, on the other hand, is a very, very light gas. To store it safely in a car, you either have to compress it to incredibly high pressures or chill it to cryogenic temperatures. Both of those are huge engineering challenges.
And that's before you even think about building a whole new network of hydrogen fueling stations. It's a monumental task.
So, after looking at the science and the real-world applications, we get to the big question. What does all this actually mean for the future of how we power our lives?
It really just boils down to this one central conflict. You've got the clean contender, the fuel cell, promising this quiet, zero-emission future. And then you have the convenient incumbent, the good old petrol engine, which is backed by a century of infrastructure. So the real battle isn't just about which technology is better, it's about which one is easier.
And as we start to weigh those options, we run into these fascinating, totally unexpected questions. I mean, a silent, emission-free car sounds like the perfect solution for our noisy, polluted cities. But what happens when we solve one problem, only to create a completely new one? Like a pedestrian who steps out into the street simply because they never heard the car coming. It just goes to show you, the future is never quite as simple as we think it's going to be.